Hi guys, how are you? Welcome all of you. I am Reena V. George from RVGMATHS Talents. Let us start the next class. See, we are doing the topic revisiting irrational numbers. We have proved the two theorems. Now we are doing examples 5, 6 and 7. Okay. See the first example. Prove that root 3 is irrational. We know root 3 is irrational, but here we have to prove that root 3 is irrational. Okay. How can we prove? See, we are assuming to the contrary, root 3 is rational. Okay. In earlier theorems we have done that. So we are supposing that root 3 is rational. Then if root 3 is rational, it can be expressed in the form a upon b, where a and b are co-primes and b not equal to 0. Okay, we are familiar with this. That means a and b have no common factors. See, we have written root 3 equal to a upon b. That means root 3 by 1 equal to a upon b. Is it? Then if you cross multiply this, what you will get? You can write b root 3 equal to a. Okay. Is it easy? Then we square on both sides. Then what happens? Square of this b root 3. That means it becomes b square and root 3 square is 3. So we get 3b square here. It is a square. So we are getting 3b square equal to a square. Okay. That means, see, this a square is a multiple of 3 and b square. That means a square is a multiple of 3. That means a square is divisible by 3. Okay. That means 3 divides a square. And we have studied one theorem. That means a prime number p divides a square. A is an integer. Then we get p divides a. This is the theorem 1.2 we have studied. Okay. So applying that theorem, you can say 3 divides a square implies 3 divides a. Is it? Okay. So a is a positive integer here. 3 is a prime. So 3 divides a. That means 3 is a factor of a. Let us denote this as a for easy to remember. Okay. We got 3 divides a. Is it? That means a is a multiple of 3. So you can write a equal to 3c, where c is some integer. Then we can substitute for a in this equation 3b square equal to a square. We get what? 3b square equal to a is 3c. 3c whole square. Then you can write 3b square equal to 3 square is 9 and c square. 9c square. 3 can be cancelled from both sides. Then you can write b square equal to 3c square. Okay. B square equal to 3c square means this b square is a multiple of 3. B square is divisible by 3. That means 3 divides b square. That means 3 divides b by theorem 1.2. Already we have studied theorem 1.2. What was the theorem? If p divides p, a prime number, divides a square, it implies that p divides a. So here 3 divides b square implies what? 3 divides b. Earlier we have seen that 3 divides a. Is it? Here we are getting 3 divides b. Okay. That means a and b have 3 as common factor. What do you think here? Earlier we have assumed that a and b are co-primes. Is it? This is a contradiction to that A and B are co-prime. The contradiction has arisen because the wrong assumption root 3 is rational. Have you understood? So this was a wrong assumption. Okay. That means root 3 is irrational. Understand? Hence we proved the example. Then come to the next example. Show that 5 minus root 3 is irrational. So we want to prove that 5 minus root 3 is irrational. How can we do? We are doing in the same way. Let us assume the contrary, that 5 minus root 3 is rational. Okay. If 5 minus root 3 is rational, we can say 5 minus root 3 equal to A upon B, where A, B are co-primes and B not equal to 0. We have done in the earlier examples, is it? 5 minus root 3 equal to A upon B. Then you can take this A upon B to this side and root 3 to that side. Okay. Then what you will get? We are getting 5 minus A upon B equal to root 3. Is it? That is root 3 equal to 5 minus A upon B. This can be written as 5 upon 1 minus A upon B. Then cross multiplying, we can write 5B minus A upon B. Okay. And what about this 5B minus A upon B? This is a rational number because B is an integer, A is an integer, B is also integer. Is it? 5B minus A upon B is rational. Okay. And so, root 3 is rational. Is it? In this equation. Which contradicts the fact that root 3 is irrational. Is it? So, a rational number and an irrational number cannot be equal. So, here this is rational. So, it should be a rational number here, root 3. But it is a contradiction because root 3 is irrational. This contradiction has arisen because of our incorrect assumption that 5 minus root 3 is rational. That means 5 minus root 3 is irrational. So we have proved that 5 minus root 3 is irrational. Okay. Then come to the next example. Example 7. Show that 3 root 2 is irrational. Here we have to prove 3 root 2 is irrational. Can you do it? Just do. Okay, let us do together. How can we start? In the same way as earlier. Let us suppose 3 root 2 is rational number. Okay. If it is rational, then what we can do? We can express that in the form A upon B, where A and B are co-prime and B not equal to 0. Okay. So we can write like this. 3 root 2 equal to A upon B. Okay. Then you can take this 3 to this side. Then it comes to the denominator. Root 2 equal to A upon 3B. Okay. Here, since A, B and 3 are integers, A upon 3B is rational. Is it? So, root 2 is also rational. But this is a contradiction. This contradicts the fact that root 2 is irrational. Is it? So, why we got this contradiction? Because we suppose that 3 root 2 is rational. Is it? So, we get or we can conclude that 3 root 2 is irrational. Okay. So, we have proved that 3 root 2 is irrational. Have you understood? So, first we suppose we are making an assumption, then we are getting a result that contradicts the assumption. That means our assumption is wrong. That is the method of proving like this. Okay, you got it? I think all of you understood this. Okay, then let us see in the next class. Thank you for watching. Okay.